And welcome back everyone to our last theorem together, the side-angle-side similarity. So if the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. So if the ratio of RS to XY is proportional to the ratio of ST to YZ, and angle S is congruent to angle Y, then triangle RST is similar to triangle XYZ. And notice here how angle S and angle Y are the included angle. So it's the angle where the endpoints of the two corresponding segments meet. And down below, we're given that angle YVZ is congruent to angle WVX. And we're given that the proportion VY corresponds to VW equals 12 over 24. But Vy has to correspond to Vw because Vy is the shorter side of triangle VYZ and Vw is the shorter side of triangle VWX. And the same is going to be true for Vz and Vx. Vz is the longer side of triangle VYZ and 36 is the longer side of triangle VWX. So Vy to Vw equals 12 over 24, which equals 1/2. And Vz over Vx equals 18 over 36, which also simplifies to 1/2. And what's important to note here is that angle ZVY and angle WVX are the included angles. So therefore, by side-angle-side similarity, triangle YVZ is similar to triangle WVX. For this example, you are to determine whether the triangles are similar. If so, write a similarity statement and state the scale factor. So if these triangles are similar, then the ratio of LM to QP will be proportional to the ratio of Ln to QR. And the reason for that is because LM and QP are both the shorter sides of their triangle, and Ln and QR are both the longer sides of their triangle. But in order to have these two triangles similar by side-angle-side similarity, we must have angle Q congruent to angle L, because angle L and angle Q are both the included angles for our triangles. But we can see that angle L is unknown. Therefore, angle M and angle Q are congruent, but they're not the included angles for the side whose lengths are given. Therefore, we could not prove that the triangles are similar by side-angle-side similarity. But even if we set up our proportions, and we reduce them to their simplest forms, the ratios formed by the corresponding sides are not proportional. Therefore, the triangles are not similar because the ratios of the corresponding side lengths are not proportional, and the included angles are not congruent. And for the next example, you are to determine whether the triangles are similar. If so, write a similarity statement and state the scale factor. So we have triangle MNP outlined in blue, and triangle MRS outlined in green. We're given the lengths for MN, MP, MR, and MS. So you know MR is 25, and MS is going to be 30. In order to compare these two triangles with side-angle-side similarity, we need to make sure that the angles that are congruent are the included angles for both of these triangles. Angle M is the included angle for triangle MNP, and angle M is also the included angle for triangle MRS. So we want to set up our proportion of MN to MR, because MN is the shorter side of triangle MNP and MR is the shorter side of triangle MRS. So what ratio? So the ratio of MN to MR is proportional to what ratio? So the ratio of MN to MR is proportional to MP to MS if these two triangles are similar. Substituting in our values, we get 10 over 25 equals 12 over 30. Simplifying both expressions gives us 2/5 equals 2/5. Therefore, the ratio of MN to MR is proportional to MP to MS. So since we have two pairs of similar sides and the included angles congruent, what triangle is similar to triangle MNP? And then what is the scale factor from triangle MNP to triangle MRS? For the next example, you are to determine whether the triangles are similar. If so, write a similarity statement and state the scale factor. Now that you've concluded the two triangles are similar, what triangle is similar to triangle AXB? What is the scale factor of triangle AXB to triangle CXD? For the next example, you are to determine whether the triangles are similar. If so, write a similarity statement and state the scale factor. First, determine if the triangles are similar. Now that you've determined that the triangles are similar, what triangle is similar to triangle FEG? And what is the scale factor from triangle FEG to triangle GEH? In example 5, Joaquin wants to measure the height of a building obstructing his view of the lake. He stands so that the tip of his shadow coincides with the tip of the building's shadow. He is 5 feet 6 inches tall, and his shadow is 18 feet long, at the same time the building shadow is 360 feet long. About how tall is the building? So what we want to do here is we want to set up a proportion, and we want to coincide Joaquin's shadow with the building shadow. And then we want to coincide Joaquin's height and the building's height. So we write a proportion that relates the corresponding sides of 18 over 360 equals 5.5 over x. Cross multiplying gives us 18x equals 1980. Dividing through by 18 gives us x is 110. So the building's about 110 feet tall. And in the last independent practice problem, you are to estimate the height of a tree if the shadow of the tree is 24 feet and a girl standing next to the tree is 5 feet tall and casts an 8-foot shadow. And you'll get the height of the tree is about 15 feet. So as a summary slide, there are 3 ways you can prove triangles are similar. The first one is by the angle-angle similarity postulate. If two triangles have two pairs of congruent angles, then the two triangles are similar. The second is by the side-side-side similarity theorem that states if the ratios of the corresponding sides of two triangles are proportional, then the triangles are similar. And note, when you're using the side-side-side similarity theorem, you want to correspond the shortest side to the shortest side and the longest side to the longest side. And then the middle side will correspond to the middle side. And finally, there's the side-angle-side similarity theorem that states if the ratio of two pairs of corresponding sides are proportional and the included angles are congruent, then the triangles are similar. And the same thing applies here. You want to correspond the shorter side to the shorter side and the longer side to the longer side, and make sure that the angles that are congruent are the included angles for both triangles. And as a final thought, if we're given that triangle RST is similar to triangle XYZ, then each pair of corresponding angles is congruent and each pair of corresponding side lengths is proportional. So because triangle RST is similar to triangle XYZ, then angle R is congruent to angle X, angle S is congruent to angle Y, and angle T is congruent to angle Z. And RS corresponds to XY equals the ratio of RT corresponding to XZ equals the ratio of ST corresponding to YZ. And that is it for 7-4. We'll see you tomorrow.